Take a good look at the environment around us. The trees, the cars, the lakes, just beautiful scenery. But have you ever wondered how small things just add up together to make this one big thing? Let's look at a building, for example. A building is just an arrangement of bricks, and bricks are just an arrangement of dust particles. Have you ever thought of it that way? Well, this and more in our video, Mole Concept. Very many dust particles are actually combined together to come up with just one brick. And then you need several of these bricks to build a house. So the concept is that very small particles combine together to form a big complex particle. Well, let's think of this in terms of matter. You need very many particles to come up with just a single atom of oxygen. In fact, one atom of oxygen has atoms so much that they are more than the buckets of water you can get from a lake like Lake Victoria. Just the atoms in oxygen are very many, more than the buckets of water you can get from a very big lake like Lake Victoria. That's quite a number. The particles in just one atom of oxygen are approximately 602,000,000. Actually, it's 23 zeros. That's a very, very, very big number. You can't even count it. If you sit down to start counting these particles, just imagine they are actually rice grains and you start counting. It's a very big number. This number is normally written in its scientific form 6.02 times 10 power 23 particles, and is known as the Avogadro's constant. It's known as the Avogadro's constant in honor of the scientist that studied this amazing concept, and the scientist is actually Amedeo Avogadro. Avogadro suggested that different matter, for example iron and carbon, is made up of different atoms. However, for any matter, it contains 6.02 times 10 power 23 particles. Particles can actually be atoms, molecules, ions, whatever. He made that iron as well as carbon have 6.02 times 10 power 23 atoms, only that the atoms in iron are heavier, because we know that iron is heavier than carbon. So that brings me back to the question, what is a mole? Well, just like we know that a dozen contains 12 items, think of a dozen of books, a dozen of brooms, a dozen of stones, a dozen of pens. We know that a dozen contains 12 items. We also know that a pear contains 2 items. Think of a pair of dry cells, a pair of scissors, a pair of birds. Then, if we know all this information about a pear and a dozen, think of a mole in like manner. What do I mean? A mole is just a group containing 6.02 times 10 power 23 particles. Yes, you got that right. A mole is just a group containing 6.02 times 10 power 23 particles. And as already mentioned, particles can be atoms, molecules, or ions. Well, let's look at some calculations to drive this point home. So a question can be set for you saying that a car has 4 tires. How many tires are on 8 cars? This is actually a very simple question. If you think about the quick math that can be done by just simple multiplication of 4 times 8, we know that 32 tires are actually on 8 cars. But I want to introduce to you a new concept which is known as the first principles of calculating numbers involving mole concept. What's so special about these first principles? It shows you where something comes from. How are you going to calculate this? We are going to start with the very first statement that we are very sure of. One car has 4 tires. So from this information, we can proceed on to the next step. 8 cars have how many tires? How will we calculate this? It is 4 divided by 1 times 8 tires. And that brings us to 32 tires. There are 2 important observations I want you to make from this. Notice that cars have been mentioned on the left and tires on the right. I call this safe practice to put the known on the left and the unknown on the right. The unknown is actually the entity we are looking for, and then the known is the entity we are actually having information on. So again, notice how the multiplication has been done in the brackets. The multiplication follows the order of the first figure on the right being divided by the first figure on the left, then the entire thing being multiplied by the last figure on the left. And that's the order I follow when multiplying figures in brackets. It takes me straight to the answer. So within 2 steps, you're already at the final answer, which is actually 32 tires according to example 1. Let's do another example and see this. Example 2 is, a chair has 4 legs. How many legs are on 3 chairs? Again, from first principles, 3 chairs have 4 which is actually the first figure on the right, divide by 1, the first figure on the left, then times 3, the second figure on the left, and that brings us to 12 legs. Again, I want you to look at the consistency in the units which have been used. Okay, now let's go to example 3 and see if this one now makes more sense. 3 girls have 19 apples. How many apples do 15 girls have? Again, from first principles, 3 girls have 19 apples. Do you notice that the statement I begin with is the statement that I have most information on? Well, if we know that 3 girls have 19 apples, then 15 girls have 19 divided by 3 times 15, which brings us to 95 apples. Well, example 4 is slightly different from the other examples. Let us look at it and see. 3 girls have 19 apples. How many girls altogether have 95 apples? So from this example, the known entity is actually apples, so as safe practice, we put it on the left. 19 apples are with 3 girls. 95 apples will be with 3 divided by 19 times 95 girls, which brings us to 15 girls. Notice the consistency of the units and notice the order which has been followed during multiplication in brackets and division. So let us relate all these examples to them all. In our example 5, how many dry cells are in 7 pairs? So you see how the example is related to all the previous 4 examples. So 1 pair has 2 dry cells. 7 pairs have, which gives us 2 divided by 1 times 7 dry cells, and that brings us to 14 dry cells. Example 6. How many pairs can be got from a basket of 24 birds? So we are going to relate birds with pairs. How are we going to start? What are you going to put on the left? What are you going to put on the right? Those are some of the questions that you should ask yourself. And according to what we've been discussing, it is expedient that we put the birds on the left. So how are you starting this? 2 birds make up 1 pair. 24 birds make up 1 divided by 2 times 24 pairs, and that gives us 12 pairs. So I think now the point is being driven home. Let us look at example 7. How many dozens can one get from a box of 96 books? We are talking about dozen and books, so we realize that actually we are looking for dozens, and that means that we are going to put it on our right. So we shall start and say 12 books make up 1 dozen, 96 books make up, it's 1 divided by 12 times 96, which gives us 8 dozens. So I think by now they are all clear. Now let's go to the real example, and this example is talking about moles and particles. Example 8. How many particles are in 2 moles of sodium? Again, please remember that particles can be atoms, molecules, or even ions. So this question can be rephrased as, how many atoms are in 2 moles of sodium? How do we start this? The unknown is particles. So because it's the unknown, as safe practice, we put it on the right, and then the known is moles. And because the known is moles, as safe practice, we put it on the left. So the very first statement that we write depends on that known truth that we have in our heads. 1 mole of sodium contains 6.02 times 10 power 23 particles. That is the known truth of this question. Where do I get the known truth? It comes from the fact that a mole is a group containing 6.02 times 10 power 23 particles. So if we know that 1 mole of sodium contains 6.02 times 10 power 23 particles, then 2 moles of sodium contains 6.02 times 10 power 23 divided by 2 times 1 particles, and that gives us 1.204 times 10 power 24 particles. A different answer is usually got by some students, and this is caused by not correctly pressing the calculator. Another safe practice is placing each value in its own brackets, that is, open brackets and place the first value on the right, close brackets, place the division symbol, open brackets and press the 1, close brackets, place the multiplication symbol, open brackets and place the 2, then close brackets, and again that's how you will get the correct answer. Example 9 is also similar to example 8, that is, calculate the number of particles in 0.8 moles of calcium carbonate. 1 mole of calcium carbonate contains 6.02 times 10 power 23 particles. The reason why we are placing particles on the right and moles on the left is because the known entity is always placed on the left and the unknown entity is always placed on the right. Our next step would be 0.8 moles of calcium carbonate contains 6.02 times 10 power 23 divided by 1 times 0.8 particles, and that gives us 4.816 times 10 power 23 particles. Let's look at example 10. How many moles are in 3.913 times 10 power 22 particles of chlorine? So in this question, the known entity is particles and the unknown entity is moles. We shall write and say 6.02 times 10 power 23 particles of chlorine are in 1 mole. 3.913 times 10 power 22 particles of chlorine are in 1 divided by 6.02 times 10 power 23 times 3.913 times 10 to the power 22 moles, and that gives us 0.065. If you have understood all that has been explained in this video, then mole concept can never pose a challenge in any way. A simple exercise to do and actually see if you have mastered the technique at heart. Answers and explanations to this exercise will be given in the next. Well, I hope this content has been very educational and encouraging, and if you like this video, please like and don't forget to hit the subscribe button below. Thank you.